Let's learn to balance equations for redox reactions in basic solution. The first 5 steps are the same. We only add 2 steps at the end. So when I say the same, meaning the same as balancing redox reactions in acidic solution. So first we separate the equation into oxidation and reduction half reactions. Then we balance the atoms. There's an order in which we balance the atoms in the half reactions. First, balance all elements except for hydrogen and oxygen. Secondly, we balance oxygen by adding H2O to the side that needs more oxygen. And lastly, we balance the hydrogens that we've introduced by adding water, by adding hydrogen to the side that needs more hydrogen. The third step is we balance the charge by adding electrons to the more positive side of the reaction. In Gen Chem 1, we only concerned ourselves with balancing equations in terms of the number of atoms, but redox reactions must also be balanced in terms of charge. And we do that by adding electrons. If necessary, we multiply the half reactions by a coefficient so that the number of electrons in both reactions is equal. Then we add both half reactions to cancel the electrons. If you're in basic solution, we must neutralize all the protons by adding hydroxide to form water. And lastly, we will simplify by canceling water if applicable. Now let's apply the rules. We have an equation. The first thing we should do is split it into 2 half reactions. We have our half reactions. We need to balance the atoms. So we need 2 iodine to balance the 2 iodine ions to balance the diatomic iodine. And also, since we have 4 oxygens on the reactant side for the permanganate and only 2 oxygens on the product side, we need to introduce 2 molecules of water to introduce the 2 oxygens. However, while we have fixed our oxygen problem, we've created a hydrogen problem, an imbalance. We've added 4 hydrogen atoms on the product side, so we must add 4 hydrogen ions on the reactant side. Now we're balanced in terms of the number of atoms, but now we must balance in terms of charge. Here we have a 2 negative charge on the reactant side for the oxidation, and we have a 0 charge on the product side, so we must introduce 2 electrons so that the reactant side and the product side both have a net charge of 2 minus. On the reactant side for the reduction, we have 4 pluses and 1 minus. That's a net of 3 plus, where the product side is 0, so we must add 3 electrons so that the reactant side of the reduction is charge neutral as the product side is charge neutral. We must now balance the number of electrons because we have 2 electrons for the oxidation, 3 electrons for the reduction. The least common multiple is 6. So if we multiply 2 by 3, we get 6. We multiply 3 by 2, we get 6. Now we have 6 electrons being given off by iodide in the oxidation, and 6 electrons gained. So we have 6 electrons that are transferred from the iodide to the permanganate ion. Now that we have the same, now that the reactions are balanced in terms of number of atoms and charge, we should now add these 2 equations together. And you can see that the 6 electrons cancel from the oxidation and the reduction. We sum the 2 equations, and we have our equation. So here is where we must do an extra step because we are not an acidic solution. This is a basic solution. So we have to eliminate the hydrogen. The way we do that is by adding hydroxide. And we have to, if we add hydroxide to the reactant side, we must add hydroxide to the product side. So we've added 8 hydroxide to each side, And you can see that 8 hydrogen ions and 8 hydroxide will give us 8 water molecules. So we'll combine them. And now you can see we've got 4 water here and 8 water here. So let's cancel the 4 water, which will leave us with 4 water on the reactant side. And we'll rewrite this so that we have our final equation.